Hello, good morning. Welcome to section 4.2. We're going to check these exercises first. So if you haven't done them yet, do them now because the answers will appear in 3, 2, 1. And here are those answers. For part A, I got ax is this vector, negative 3.5, comma, negative 0.75. Which you can see is not a scalar multiple of x when you draw a picture of it. Scalar multiples of x are all like on the x1 axis. So like something like that or like that would be a scalar multiple of the x vector, but ax is not. And for a times v, on the other hand, you get this negative 8, negative 2 vector just over here, which is a multiple of v. So a times v is negative 2v. And yeah, so that's that one. That was pretty straightforward. Exercise 2 can be tricky if you haven't mastered the notation of coordinate vectors relative to a basis. So we have a basis, which is the list of vectors, which is basically the same thing as the matrix P here. It's just that one we're thinking of as a matrix with rows and columns and everything, but identifying it with a basis B. So when we have this thing here for part A, we want the B coordinates of B2. Remember, what that means over here is the B coordinates of something is what are the weights of the basis vectors in order to make the corresponding linear combination become B2, the thing on the inside here. And that should be all zeros, except for the second one should be 1, because you want to just do 1 times B2. So what is the vector that has all zeros except the second entry is a 1? That is just the vector E2. And because you can also think of this linear combination here as the matrix P times the vector that has those weights as entries, the coordinate vector. So we get B2 is equal to P times this coordinate vector. You could just multiply both sides of this equation by P inverse, and you get P inverse times B2 gives you the B coordinates of B2. And that is why this one also works. For part B, this is the same idea as that last thing we were saying. It's just that we have E3's B coordinates instead of B2. So the B coordinates of E3 are the weights you multiply by the columns of P to make that linear combination come out to be E3. And so just multiplying both sides of this equation by P inverse gives you what you want. And part C is the same idea, just in a slightly different order here. It's just if you want to get B3, you just multiply the third column of P by 1, and the others are 0, and that gives you B3. So that one's kind of maybe more straightforward than the other ones. So yeah, this was just to remind yourself of the way that coordinate vectors work, and you can represent it as matrix multiplication or as a linear combination, and we'll be using this in a little bit. In the next video, we will talk about what are eigenvectors and eigenvalues really. So I'll see you then.